Okay. Now when you have autosomal dominant trait, look how different this pedigree looks from the previous one. Autosomal dominant is going to be dominant. If you're going to inherit an autosomal dominant trait, your parents, or at least one of your parents, is going to show it. There's no way that you inherit an autosomal dominant trait if your parents don't show it. So here you see, parents one shows, child shows. Okay, does not skip generations, and it also shows up with the same rate or the same frequency between men and women. Okay, so this one is the X-linked recessive trait. Okay, X-linked recessive means it's a sex chromosome, it's an X chromosome, and it has to do with the recessive gene, right? It's not a dominant characteristic. So X-linked recessive, what happens is that it tends to show up in men more often than it shows up in women. Okay, why? Because again, men will have only one of the X chromosomes, and then women have two. If it is recessive and it gets one of the good genes, so it's not going to show up that trait, the particular trait. So you can have several generations that are just not showing up the trait, just like the autosomal recessive genes. It tends to skip generations as well. See, no show here, but yes, obligate carrier, because if it's going to show up later and is X-linked, so at least the mother had to carry it. If the father was carrying the gene here, then this father would show up the trait, right? He only has one X chromosome. So here, this is an obligate carrier because somebody came up with the disease, and we know it is X-linked. Now, after, you see the generation down, you're skipping generation, so nobody's showing up the trait here, but you know that at least this person has to be a carrier, because then the gene shows up again, the trait shows up again. And you notice that it is skipping generations, okay, and it's mainly showing up in men. Yeah, you can have a woman with it, but then in order to have a woman that has this particular trait, you are going to have what? You're going to have a father that is showing the characteristic. Okay, and you have to have a mother that is an obligate carrier.
In this chart, right, so it's not set in stone that if your mom's a carrier, that all the boys will get it.
No.
It's just a higher chance.
It's a higher chance because the boy is going to inherit only one of the X chromosomes, but he could get the bad X or the good X, right? Now, if the father is carrying, is showing the trait, you know that all the daughters are going to be obligate carriers, because the only way they're going to be girls is by inheriting that X chromosome from the father, and the X is what's causing the trait. Okay, so these are going to be obligate carriers. Okay. Now, when you have X-linked dominant trait, okay, so this is linked on the X chromosome, it looks pretty much like the autosomal dominant trait, and the difference is that it's not going to skip generations, and usually if a person does not inherit the gene, it's never going to show up again. If it is an X-linked dominant and here the father has it, right, and now the mother doesn't have it, maybe it is a carrier, maybe, oh, actually it's not a carrier, because if it was a carrier it would be dominant, right? We know this person is not a carrier. So now these people have a child here. Let's see the first one, the girl has. So this person here, we know that is X, big A. And now the other one, it could be, it has to be that, because this person is not showing it, right? So in order for this person not to show the characteristic, he has to be recessive. So you already know the genetic composition of this person here, right? So let's see if this person here gets together with somebody else that is X, little a, and Y, not showing genetic characteristic. And then they have a child here. Let's say it's a girl that is X, little a, and X, little a. Is this person going to express the phenotype? No, right? So look what happens. The gene disappeared. Dominance of this trait here disappeared, because from this line on, there's going to be no phenotype expressed based on that trait. Okay, X-linked autosomal, X-linked dominant. Okay, So you see from this side of the family here, you know, this person had it. It was X dominant. Now the daughters have to have it because it's dominant, and the daughters have to have the X chromosome coming from the father, right? One from the mother, one from the father. So this boy here did not inherit the X chromosome from the father, right? He has to inherit the Y, and the mother was recessive. So this side of the family here, the trait disappeared. Now from this side here, it's going to show up again. Now this is the easiest one to detect, right? Y-linked. All the boys will have it. All the boys in the family that have it, and they have boys, the boys will have it because it's on the Y chromosome. Okay? So boy had it, boy have it, boys, all the boys have it. Now have a boy, they'll have it. More boys, they will have it. Okay? So the easiest way to remember a Y-linked trait, what would be the easiest way to associate the expression of a Y-linked trait? Exactly. You associate it with a penis. Okay. If you have a penis, you have a Y-linked trait. Okay? But, you know, this is another study strategy. You make something ridiculous out of it that you can remember all the time, you never forget it. So this is just a little more review that you can go over, you know, just to see exactly what you're talking about. Okay, autosomal recessive, autosomal dominant, and how is it showing up? Okay. Recessive, we just covered that. X-linked dominant, we just covered that as well. Now another thing important about the X-linked dominant trait is that you tend to see it more in girls than in boys. Because now, if you have a boy that is coming up from, let's say, a couple like this, and you have a boy that is expressing it, okay, it's going to have one X coming from the mother and then the Y coming from the father. So you know that it's going to have only one chance of inheriting that X chromosome, right? Now, the girl, since they only have, X chromosomes here, their chances, if it is dominant, the chances are that if he inherits the gene is going to show up. Okay, I put those just for practice on what to do. So if you look something like this, first guess that you have is what? Does it skip generations? That's the first question you ask. So you can bet it's some form of dominant trait. Does it affect men and women at the same rate? Yes. Okay, so it could be X-linked dominant. So the first thing you do to solve a problem like this, you eliminate the recessives. So you get 2 down out of 5. So can it be autosomal recessive? It could be autosomal dominant. It could be X-linked recessive. It could be X-linked dominant. And it could be Y-linked. Is it Y-linked? No, this one is out. Easiest one to cross out. Girls have it, it's not Y-linked. Is it recessive? Most likely not. It's not jumping generations, so you get here to the recessive and you cross them out. So you're left with autosomal dominant or X-linked dominant. Is autosomal dominant, because remember the X-linked dominant will tend to show up more in girls than in boys, right? So this you can say autosomal dominant. After you figure out what it is, don't just say, oh, Eureka, that it is, right? Go back to the problem and confirm your answer. Okay, so now you go here and you say, okay, these 2 guys here, the first one is dead, poor thing. That is a widow, showing the trait. So now you have 2 kids that came up here. One is a girl that is expressing, one is a boy that is expressing. So yeah, that tells you it has to be most likely dominant, right? So here we go. I'm betting it is autosomal dominant. So here we go. Big A, the other one doesn't matter, or you don't know what it is. You only need one of them to express the trait, right? And this guy here was little a, is not expressing the trait. Now, the possibilities that come up here, it could be what? Big A, little a, or it could be, is not little a because it's expressing, right? And then this person here has to be also big A, little a, because it is expressing. So you come down the line and you go, okay, next one, this guy is marrying, okay. What happened? Oh, it's a widow that remarried. Sometimes it gets a bit confusing. Okay, so here we go, a dead man. And you have here, one is pressing, another is pressing. So let's figure out this part first. This dominant, yes, has to be dominant in something else. This one has to be dominant in something else. You know, something else has to be little a, because this guy wasn't expressing. So these two are heterozygous, right, carriers. So after this guy is here, let's come down from this chain here. You marry somebody that is not expressing, and you have somebody that is not expressing. Could that happen? Yes, little a, little a. So we got this one here, yes, little a, one from mom, one from dad. So yeah, that makes sense, right? This is how you confirm that your guess is correct. Because if you come down the line and you're putting those autosomal genes in there, you know, little a, big A's, and little a's, big A's, and you come to a point that it doesn't make sense, so you know something is wrong with your guess. So then you go back and you say, oh, I don't think it's this one here, I think it's this one here. Okay? And if you're still not convinced, then you can say, oh, it could be autosomal dominant, it could be X-linked dominant. You can give two possibilities. Now, in case of an exam question, and you put only one of them, that's fine, you get full credit. Now, if you put both of them, that's fine, you just get full credit. So you just have to give a concise, well-explained answer of what the thing is. All right. So I put just more practices here, so you can try it out. So how about this one? Recessive jumps generation. Looks like recessive. You think it's autosomal or you think it's X-linked? Autosomal. Although the ratio here is hard to guess because it's one woman and one man that came up with it. So, you know, but it looks like autosomal recessive. Okay, and in fact, oh, this one is, you know, X-linked what? Recessive, because if it was dominant, the carrier will show it, right? So, you know, you see something like this is a giveaway. You see the little dot, you know it has to be.
How come the father doesn't have a carrier sign on him then?
How many X chromosomes does the father have? That's why. Okay, either it shows or it doesn't show. If he has the dominant allele, it will show. If he has the recessive, it's not going to show. It's easy to analyze the man.
Because when you show the chart,
that for autosomal carriers, you never put the dot. Okay? So if you put the dot, it's usually X-linked, recessive. Okay? Otherwise, you don't have to figure out anything. You know. Okay. Analyzing the pedigrees. But then this is really all common sense. Just write everything down. And even if you don't remember, oh, is it jumping generation? Is it not? Well, jumping generation has to be recessive. You know, even if you don't remember all that, and you write this down, and you can figure out what the genotype is supposed to be. Okay? And you can just assign random chromosomal letters to each person in this pedigree, and then you go down the line and figure out if it makes sense or not. Based on that, you can eliminate your options.